This is the last example problem, and it's example number 7. It tells us that 43.9 milliliters of oxygen has a mass, mass of 36.0 grams. Wants to know what's the amount of gas in moles when the volume changes to 39.5 milliliters. Now this one is a little more tricky because we don't have pressure, volume, and temperature changing. We have volume, but what's this other thing, this amount? The amount in moles. Okay, so that is going to be involving the other form of the combined gas law that includes in. So if you look at our form of the combined gas law, up here, it's PV over NT. So N is in the denominator with temperature. Okay. Apologize, my computer's catching up with me. There we go. So I have volume and N. The amount is the number of moles. V1, N1, V2, N2. This is also Avogadro's law. It will be given to you on the test. I'll give you Avogadro's law, but you need to know how to use it. V1 is 43.9 milliliters, and it tells us the mass is 36.0 grams. Remember that N has to be in moles. So right now I have grams of, and it tells us what the gas is, it's O2. I'm going to have to convert that to moles. So I will multiply by 1 mole over the mass of oxygen. Well, oxygen has a mass, just the oxygen atom has a mass of 15.999. So if I wanted to know the molar mass of O2, I would need to double that 15.999. That gives you 31.998 grams per mole of O2. So I'm going to do 36 times 1 over 31.998, and I get 1.13 moles of O2. Then we get to V2. V2, our other volume, is 39.5 milliliters. And then N2 is what I'm looking for, and that's going to be in terms of moles. Again, our equation is V1 over N1 equals V2 over N2. So I'm going to put 43.9 over 1.13 equals 39.5 over N2. To solve for this, we probably want to cross multiply. So I end up with 43.9 into equals 1.13 times 39.5. To get into by itself, I need to divide by 43.9 on both sides. For N2, I end up with 1.02 moles. All right, that's it for these example problems. We'll have a worksheet for you guys to work on to see how you do multiple choice questions.